Hello students, how are you? I hope all of you are good. In previous video, I started a new chapter vector algebra and we discussed the introduction part for the first exercise, that is 10.1. That is what? 10.1. So in this video, I am going to discuss the introduction part for the second exercise, that is 10.2. That is what? 10.2. And for solving the problems in exercise 10.2, we need these following concepts. So if you perfect all these 8 concepts, then we are going to solve easily the problems in exercise 10.2. In that, the first concept is triangle law of vector addition, and second one is a parallelogram law of vector addition, and third one is position vector of a point, and fourth concept, most important concept, is direction ratios and direction cosines of a vector, and the fifth one is components of a vector, and then vector joining 2 points, and seventh one is properties of algebra of vectors. Algebra of the vectors is nothing but addition of vectors, subtraction of vectors, multiplication of vectors, and last one is a section formula. This is also one of the most important concept. So let's start the first concept. What is the first concept here? Triangle law of vector addition. So first concept is triangle law of vector addition. The first concept is triangle law of vector addition. Triangle law of vector addition. So this is nothing but one of the graphical approach of the vector. Triangle law of vector addition. See here. Suppose A vector and B vector are the two adjacent sides of a triangle. Suppose A vector and B vectors are the two adjacent sides of a triangle taken in a cyclic order. Taken in a cyclic order. Nodri, direction is same. Taken in a cyclic order, then the third side of this triangle, taken in a reverse order, representing the resultant of these two vectors. Resultant in the sense sum. So the third side of this triangle, which is taken in reverse order, represents the resultant of these two vectors. Means this vector, means third side of this triangle, represents the sum of these two vectors, A vector and B vector. So this is what say this triangle of vector addition. Hope all of you understood. In your statement, suppose A vector and B vectors are the two adjacent sides of the triangle taken in a cyclic order. Then the third side of this triangle, which is taken in a reverse order, representing the resultant of these two vectors, A vector and B vector. I hope all of you understood. Statement node another. If A vector and B vector are two adjacent sides, of a triangle, taken in a cyclic order, taken in a cyclic order, or taken in cyclic order, then the third side, of the same triangle, then the third side of the triangle, third side of the triangle, taken in reverse order, represents resultant of these two vectors. Represents resultant of these two vectors. Represents resultant. Represents resultant. Resultant in the sense sum of A vector and B vector. I hope all of you understood what this triangle of vector addition is actually. So let us consider some one example. Suppose this is a x vector and this one is a y vector. Let x vector and y vectors are the two adjacent sides of this triangle taken in a cyclic order. Then the third side of this triangle taken in reverse, representing the resultant of these two vectors, that is x vector plus y vector. I hope all of you understanding. So let us consider one more example here. Let's suppose this is one of the triangle whose vertices are A, B and C. A, B and C, and let CA vector and AB vector are the two adjacent sides of the triangle ABC taken in a cyclic order. Then the third side of the triangle CB taken in the reverse of these two vectors, representing the resultant of these two vectors, that is what CA vector and AB vector. Therefore, from the triangle of vector addition, this can be expressed as CA vector plus AB vector equal to CB vector. This is what actually triangle of vector addition. CA vector and AB vectors are the two adjacent sides of the triangle taken in a cyclic order. Then the third side of this triangle CB taken in a reverse order, representing the resultant of these two vectors, CA vector and CB vector. So let us consider one more example. Let's suppose PQR is any one of the triangle. In that, QR vector and RP vector are the two adjacent sides of the triangle PQR taken in a cyclic order. Then the third side QP, which is taken in a reverse order, representing the resultant of these two vectors. That is what QR vector plus RP vector equals to QP vector. I hope all of you understood the triangle of vector addition. So what is the next one? Next one is a parallelogram law of vector addition. Second one is a parallelogram law of vector addition. See here, what actually this parallelogram law of vector addition says us. Let us suppose let A vector and B vector are the two adjacent sides of the parallelogram which are initiated from the same point. So as you know that parallelogram, the property of the parallelogram is opposite sides are equal and parallel. It means if this side is A vector, then this vector is also what? A vector. Since they are equal, it means to take magnitude as well as direction is same. And then if this is a B vector, then its opposite side is also representing the B vector. Now A, B, C, D is one of the parallelogram. So this is also what? One of the B vector, because from the properties of the parallelogram we know that opposite sides are equal and parallel. Now see here, if A vector and B vectors are two adjacent sides of the parallelogram which are initiated from the same point, then the diagonal of the parallelogram which is initiated from the point which are initiating from these two A vector and B vector, resulting the resultant of these two vectors. It means this diagonal which is initiated from same point where there is this A vector and B vectors are initiating. So this diagonal representing the resultant of these two vectors, A vector plus B vector. I hope all of you understood. What is the statement? If A vector and B vectors are the two adjacent and co-initial sides of the parallelogram, then the diagonal which is initiated from same point as that of A vector and B vectors are initiated, that diagonal represents the resultant of these two vectors. See here, another statement, if A vector and B vector are two co-initial and adjacent sides of a parallelogram of a parallelogram, then the diagonal then the diagonal then the diagonal which is initiated from the point where A vector and B vector are initiating represents what? Resultant in the sense sum of A vector and B vector. I hope all of you understood this parallelogram law of vector addition. And one more thing you may observe here, just observe the triangle ABC. So here also A vector and B vector are the two adjacent sides of the triangle ABC taken in the cyclic order. Then the third side AC, which is taken in reverse of these two A vector and B vector, representing the resultant of these two vectors. I hope all of you understood. In this first triangle ABC, the triangle of vector addition is also satisfied. And in the second one, so observe here, in the triangle ADC, the vector B and A are the two adjacent sides of the triangle ADC taken in a cyclic order. Then this third side of the triangle ADC, that is what? AC, taken in a reverse order, representing a resultant of these two vectors, that is what? B vector plus A vector. So it means AC vector is A vector plus B vector or B vector plus A vector. It means we can say that vector addition is commutative. What is a commutative law? A vector plus B vector is equals to B vector plus A vector. So in vector addition, the vector addition is commutative. I hope all of you understood the parallelogram law of vector addition. So let's start the third concept. And the third concept is position vector of a point. See here. Suppose let us consider one of the Cartesian plane with x-axis, y-axis and z-axis. Let this is the origin. Suppose P is one of the point in space, and the coordinates of the point P is x, y and z. The position vector of this point P is OP vector. Is what? OP vector. So to say the position of any point, we need one of the fixed points. So that fixed point in vector we consider as what? Origin. So position vector of the point P is what? OP vector, where initial point is O, terminal point is P. So therefore, position vector of the point P is equals to what? OP vector. Similarly, position vector of the point, position vector of the point, position vector of the point of the point Q is equals to definitely OQ vector. Similarly, position vector of the point A is OA vector, and similarly position vector of the point R vector is OR vector. I hope all of you understood. And one more thing you need to observe here, what is magnitude of OP vector? What is magnitude of the OP vector? Magnitude of the OP vector is nothing but length of OP vector. Length of the OP vector means distance between this terminal point and initial point. As you know that the coordinates of the point origin is 0, 0, 0. So means we need to calculate the distance between the points O and P. And as you know that the distance between 2 points, the formula is given by square root of x2 minus x1 whole square. What is the distance formula which is studied in our 10th class? Distance formula, let's d is equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So here let's say origin point, the coordinates are x1, y1 and z1, and this point is considered as x2, y2 and z2. So distance between the points O and P is given by x2 minus x1 means x minus 0. What is x2 minus x1? X minus 0 whole square plus y2 minus y1, y minus 0 whole square plus z2 minus z1, z minus 0 whole square and under square root. Therefore, magnitude of OP vector is x minus 0 whole square is x square plus y minus 0 whole square is y square plus z minus 0 whole square is z square. I hope all of you understood. The formula for calculating the magnitude of the vector is square root of x square plus y square plus z square. It is nothing but coordinates of the points P, x, y and z. I hope all of you understood the position vector of the point P. And what is the next concept? Direction ratios and direction cosines of a vector. One of the most important concept. Next concept is direction cosines. Direction cosines and direction ratios of a vector. Direction ratios of a vector. See here. Direction ratios and direction cosines. So let's suppose this is one of the coordinate axis, x-axis, y-axis and z-axis, and this is the origin. And suppose let this is a r vector, which makes an angle alpha with the positive x-axis, beta with the positive y-axis and gamma with the positive z-axis. The angles made by the vector with positive x-axis, positive y-axis and positive z-axis are called as direction angles. What are the direction angles here? The direction angles are alpha, beta and gamma. So first thing, direction angles. Here the direction angles are alpha, beta and gamma. And what are these alpha, beta and gamma? Angles made by the vector with the positive x-axis, y-axis and z-axis respectively. And the cosine of these direction angles are called as direction cosines. Cosine of the direction angles means cosine is nothing but one of the trigonometric ratio. So simply we call it as what? Cos. So cosine of the alpha is cos alpha and cosine of the beta is cos beta and cosine of the gamma is cos gamma. And these cos alpha, cos beta and cos gamma are called as direction cosines. And mainly the direction cosines are denoted by the letters L, M and N, where L is cos alpha, M is cos beta and N is cos gamma. I hope all of you understood. And here we need to discuss one more thing. See here, suppose this is a point P, the position vector of the point P is OP vector and OP vector is defined by what? R vector. And suppose the coordinates of the point P is x, y and z. X, y and z. So if I draw a perpendicular line from the point P, to the positive y-axis, then definitely OQP is one of the right angle triangle. And for this right angle triangle, for the measuring angle beta, PQ is the opposite side and OQ is the adjacent side and OP is a hypotenuse side. I hope all of you understood. And as you know that if the point is XYZ, then y coordinate of the point P is y, hence length of OQ is equals to y. And opposite side along the z axis, therefore its coordinate is z. And as you know that OP is a hypotenuse of the triangle and it is represented or it is defined by the vector r, and hence its length is equal to what? Its length is equals to magnitude of the r vector. So its length is equals to what? Magnitude of r vector. Magnitude representing what? Length of the vector. So therefore length of OP vector is magnitude of r, or simply magnitude of r vector can be represented as just r. In my previous video I discussed each and everything, magnitude of the vector and how you representing the magnitude of the vectors. Now see here, in the right triangle OPQ, cos beta is equals to adjacent by hypotenuse, adjacent divided by hypotenuse, and adjacent is y, the length of adjacent is y, divided by hypotenuse, length of hypotenuse is r. Therefore as you know that cos beta is equals to m, hence the value of m is equals to y by r. I hope all of you understanding. Similarly you can feel, the value of cos alpha, definitely equal to what? X divided by magnitude of the r vector, because alpha is the angle made by this vector with the x axis. Therefore cos alpha should be equal to x divided by r, and hence cos gamma is equals to angle made by the vector with the z axis is gamma. Therefore cos gamma is equals to z divided by magnitude of r, and as you know that cos alpha means L and cos gamma means N. So we got the value of L is x by r and the value of N is z by r. Now observe this carefully. See here, from this y by r equal to m, we can write it as y divided by m is equals to r. And by the relation x by r is equals to L, we can write it as x divided by L is equals to r. And from the relation z by r is equals to n, we may write it as z divided by n is equals to r. Now from these three relations, we conclude that y divided by m equal to x divided by L equal to z divided by n. Now observe here, L, M, N are the direction cosines. And these x, y, z are the numbers which are proportional to this L, M, N. That's why it is equals to R. So the numbers x, y and z are the numbers proportional to what? L, M and N. And these numbers are called as direction ratios. Actually the definition of direction ratios is the numbers which are proportional. The numbers which are proportional to the direction cosines are called as direction ratios. And direction ratios are denoted by A, B and C, where A is X and B is Y and Z is C. I hope all of you understood. And one more thing you observe here. So OP vector, what is the magnitude of the OP vector? Magnitude of the OP vector is R. And as you know that magnitude of the OP vector is square root of x square plus y square plus z square. And what is R square? R square is equals to x square plus y square plus z square. So if we squaring on both sides, square root get cancelled on right side. And observe here, the value of L is x by r, m is y by r, and n is z by r. If I squaring and adding this L, m and n, suppose let's consider L square plus m square plus n square, which is equals to nodri enagutte value of L is x by r, then L square should be equal to x square divided by r square, plus value of m is y by r, then its square is y square divided by r square, plus value of n is z divided by r, then its square is z square divided by r square. Now observe here, in each term denominator is r square, hence LCM is r square. So it becomes what? X square plus y square plus z square divided by r square. And we know that x square plus y square plus z square is equals to r square. So it means numerator can be replaced by r square divided by r square. So r square get cancelled, which is equals to 1. So finally we got ಇಲ್ಲಿ ಬರೀತು ನೋಡ್ರಿ, the relation between direction cosines of a vector is L square plus m square plus n square is equals to 1, one of the most important relation. Or you can also say that L equal to cos alpha means L square is cos square alpha plus m square means cos square beta plus n square means cos square gamma, which is equals to 1. I hope all of you understood. Most important relation between what? Direction cosines of a vector. I hope all of you understood this concept, direction cosines and direction ratios. Direction cosines means cosine of the direction angles, where direction angles are angles made by the vector with the positive x, y and z axis. And direction ratios means the numbers which are proportional to the direction cosines are called as direction ratios. Direction cosines are denoted by L, M and N, and direction ratios are denoted by A, B and C. I hope all of you understood. And the most important thing is the relation between direction cosines of a vector. That is what? L square plus m square plus n square is equals to 1. I hope all of you understood.